Okay, I was going to actually attempt to do this lab on video like I had told you, but then I realized it's not super duper helpful for me to just put it down here and you just look at bubbles. So I'm going to talk you through some of this, and then I'm going to talk about a couple of other things. And that is when I will tell you about the lecture assignment. So this is the PowerPoint that should go along with the lab you're supposed to be doing at home. Those of you who wanted the materials that I had brought into lab yesterday, I sent it home, so you should be able to do this. Now, this is all about bubbles and surface tension. In chapter 2, when we talked chemistry, we talked about surface tension, and so there you go. That is the entire secret to making bubbles. If you have ever washed your dishes by hand and you've squirt the soap in there, sometimes randomly you see that little bubble that goes flying off. You see the whole sink fills up with bubbles and that kind of thing. That's what it is. If you do just water, you might have what looks like bubbles, but it's like you're blowing in a straw. It goes, makes the bubbles because the hydrogen bonds, it's like, just kind of slightly stretching, but they always pop. You add the soap, the bubbles get bigger, they go farther. If you've ever played with a kid with bubbles, you have the wand, you can take it out, you'll see that the water has stretched. There's that little film, and if you in it, it just breaks. But you do that with soap, and you go, you see it slowly expand. That's what this is about. So, like I was just saying, if you try to make bubbles using normal water, it doesn't work. Forces holding the molecules of the liquid together is too high, so it just breaks. If you remember, I also talked about like when it gets hot, it turns into steam. It's because it's the bonds breaking that is causing it to happen so fast. When you add the detergent, it lowers the surface tension, and so it allows it to expand. For this lab, we're adding corn syrup or glycerin because this is to, again, help it expand a little bit more, so it kind of takes away some of the surface tension. So, in a container of water, we talked about this in class, the water molecules are attracted to each other. Remember those promiscuous hydrogens that I was talking about? They're like hooking up, catching up with everything. So they're constantly wanting to be with each other. So they're always pulling and pulling and pulling, and that's what's happening. Surface of the water molecules attracted to the water molecules that are all around them and below. No water molecules above to be attracted to since it's air. So it's here and down here. That's what causes the surface tension. This is the reason why if you take a thing of water, and I totally meant to have a bowl of water here when I did this, and then I was afraid I would spill it and break the computer because this is a new laptop because my other one died recently, so I got a little afraid. Anyway, if you take a thing of water, you can have it be a bowl, you can go to a tub, a pool, whatever, and you just take your hand like this and smack it. Again, just like a belly flop. I talked about that in class last week. But you can just smack it with your hand. It's like, pow! You would think your hand would just go through it, and if you go slowly, it goes through it. But if you pop it like that, it hits. You will hear it, you will feel it, and that's because of the surface tension. The water molecules are trying to hold on to each other, and if you go too fast, it kind of holds on. If you add something to it, it's a little bit different. That's what we're talking about for our bubbles. So, when soapy dish detergent's added to the water, it's going to lower the surface tension so bubbles can form. The detergent molecules will increase the distance between the water molecules, and so since it's increasing the distance, it's making it a little harder for them to hook up. And so that makes them stretch a little bit farther, which makes it possible to blow bubbles. So your procedure for this lab, you are going to have the 3 cups, and some of you got the 3 cups that I gave you. For the cup I gave, I normally put about this much water, and Here it says add 2 tablespoons of detergent. You can do 2, you can do 1, just be consistent across all 3 cups. The reason I say you can do 1 or 2 is I've done it both ways. If you do 2 tablespoons of detergent, it's a lot easier to blow the bubbles. So that's the smartest. And it doesn't have to be like a measuring spoon. It's just use the same spoon for all of your measurements. So put your soap into the waters, mix them up, all 3 of them up. At this point, that's the last time you're going to use the same spoon to touch into each cup because you do not want cross-contamination. Now, when you mix it, you're going to see a little foam up there. That's, of course, because of the soap. So the first thing you should be thinking about is why did you need to add detergent to all of the solutions? Well, there's a couple of reasons. 1, without the detergent, you're not going to be blowing bubbles. And 2, control. When you're doing a proper scientific experiment, you need to know exactly what to expect. So notice we are testing corn syrup and glycerin. So one of the cups is your control. So all 3 start exactly the same. Then in the glycerin cup, you're going to add a spoonful of the glycerin. Put that in there and stir it up. Take your spoon out. Wash your spoon. Make sure it is totally clean. Yes, you can use a different spoon. I tend to just clean in between. Yeah, entirely up to you, but you do not take the glycerin spoon and put it in the corn syrup one. That's a big no. Now, on the other cup, the last one that says corn syrup, you measure in a spoonful of corn syrup. Put it in there. Stir it up, make sure it's blended, wash your spoon. Now you can put your spoon away. Now, here you're supposed to take a look at the consistency of the glycerin and the corn syrup. Yesterday in class, I held up both bottles and I turned them and showed you exactly what each one looks like. One of them seemed a little bit more viscous, which means it was thicker, sticky. And anyone who was standing even remotely near me heard me when I went, because my fingers stuck all over it. Then I tried to clean it with a tissue, and I don't know if anyone saw that. Tissue stuck all over the outside of the bottle. It was ridiculous. Anyway, one of them is more viscous than the other. Here they're asking, do they look about the same? Mine sure as heck did not. So take a look at your stuff and think about it. You've got them all mixed up now, so I should have actually changed those. Now, you should have 3 different bubble wands. 1 for your control, 1 for the glycerin, and 1 for the corn syrup. You're going to try to blow bubbles now. It's going to take a little while. Most people haven't blown bubbles in quite some time. I highly recommend it. I love it. This is one of my favorite labs. The only sucky part about this lab for me was 2 years ago. The day I did this lab is when I got contacted that my aunt, my mom's twin sister, had passed away. And so in my head now, I actually connect the bubble lab with my aunt passing. And so that's the one there. But it's still a really good lab. It's fun. And if you allow yourself to have fun, it's a blast. It's not supposed to be a chore. I personally think labs are supposed to be fun, entertaining, and get you to really appreciate it. So if you are absolutely positively despising this lab, try to engage your inner child because bubbles are so friggin' cool. But anyway, now you're blowing your bubbles. Some people catch it back on the wand. This is going to depend on how well you made your wand. A lot of times I still have a metal piece sticking out and then I pop it, and that's not great. Also, if you have something like this, cover your skin and you can bounce your bubbles on your arm and your hand, but then as soon as you do that, if it hits your skin, it's going to pop. So kind of fun. Every quarter I ask people if anyone knows how to juggle because I desperately want to see someone try to juggle the bubbles. I don't know why, it's just a thing. I want to see it. You are going to have to practice blowing the bubbles because each one of those is changing lowering the surface tension. So the amount of air you're blowing to blow the control bubble is going to be different than the air you're blowing for the glycerin versus the corn syrup bubble. They are all 3 different ways of blowing bubbles. And I know it doesn't seem like it's that big a deal. Trust me, it'll take a little while to figure this one out. But once you master blowing the bubbles, then you can start seeing how long they last. Where it says here, it might be helpful to have another person time you. We're not going to worry about official times, not unless you find one that's really lasting and you're just curious. So I want you to blow multiple bubbles. Here where it says calculate the average bubble lifespan for each solution, we're not doing that on the one you're doing at home. We're not. So don't even worry about that. I'm going to scooch over to here. What I want you to do is actually spend time with each of them. You need to have multiple bubbles make it past the wand. So float, that kind of thing. I do want you to try to catch them, or if they land on the table around you, keep an eye on them. I want you to figure out which of these last the longest, which one lasts the least amount of time. I would like to know, were you able to bounce the bubbles, play with the bubbles? If so, which one worked better? Did the control work the best? Did the glycerin work the best? Did the corn syrup work the best? Which one actually made the biggest difference to you? Did some of the solutions successfully make larger bubbles than others? And if so, which solution? Were you able to make like a really big bubble and did it last? Or did it just make a really big bubble and then as soon as it came off the wand, it was so heavy it broke? That happens sometimes. I want your feedback. I want to know all about your bubbles. This is all the science behind it. Go ahead and read over here. Notice we're talking about the hydrophilic, hydrophobic again. So all of this is stuff you should be looking at after you have blown your bubbles. And then we have your questions. These are your technically official questions. So just turn this kind of stuff in. Now, obviously you're not turning it in person. So I'm going to show you here. Hey, there's my recording. Bubble Lab questions. This is if you want to just see the questions. It's the same. It's like seriously copy and paste from the PowerPoint, so you don't really need to worry about those. You can look at them whichever way. You have your lab report 2. Your lab report 2 is the one you normally see. But what I need you to do to prove to me about the Bubble Lab, since we're not able to do this in person because, masks and you can't blow bubbles wearing a mask, you need to send me either video of you doing the lab, so like blowing the bubbles, showing me the aftermath, a bubble that's lasted a long time, that kind of thing, and or pictures of your setup and again the aftermath, because I know what it looks like when somebody's been doing this for a while. I have taught this lab enough times. I know exactly what the table around you should look like. If you have kids, let them join you. Have fun. Kids love this lab and it can show them how fun science can actually be. So for the Bubble Lab, you need to go through the PowerPoint and actually conduct the lab. And then you need to be taking pictures. Pretty much everyone I know has a smartphone, so you are capable of taking pictures. Just email it to me. Email it to me here. Right there, the lbernhardt@gmc.edu. So email it to my email address. I would say send it through Moodle if you want to, but I'm not positive for the messages in Moodle about making attachments. But you can email me attachments. I want photos. I want proof that you're the one who did it and your questions. So give me an idea. Yes, I could open an assignment here and I might in just a moment. So if you see assignment, then do it there. I'm giving you the option either way. Either way, if you do it, you then get points for it. So please, please, please do the Bubble Lab and have fun. Now, The other lab this week is the fatty acids scenario. Fatty acid lab. This right here is the actual lab. Above it is the scenario. You need to open this and look, because will it open? Yes. This one is a whole lot of information. If you open this, and notice I even put notes in here. I tried to show you some things, point out some things. So if you actually go through this, you will have the information you need in order to do the lab. After that, it's just you using your own brain power for it. So these are your labs for this week. Make sure you do those. Now, for the lecture assignment. Lecture assignment 2. This video counts for that as well. So, your lecture assignment 2. I am going to require a couple of things. 1, I want you to tell me that you have completed your labs. Tell me what you thought of both labs. What was your favorite and least favorite parts of both labs? Tell me if you think the bubble lab would have been better in person, like in lab if we were able to do it, or how difficult or how easy it was to do it at home. I do want to know how this works, because if we are still in this whole mask wearing and everything next quarter, which I think we will be, I need feedback. I need helpful feedback for the next quarter people. Yes, I know that won't help you, but it will help the next batch of students. So I need your feedback. The other thing is, so far in class, I've had to remind a couple of people, and I'm not talking just your class, but both classes I teach, I've had to remind multiple people to keep their mask on. I've had to remind people it has to be over the nose. I have seen plenty of people with masks that are just very loose here, and it's kind of like watching someone's pants fall off their butt. I'm watching the mask slide, 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 and it's 1, very distracting, and 2, it's rather dangerous. No matter what your personal opinion is about wearing a mask and why you might want to wear it or why you might not want to wear it, I want you, for your lecture assignment, to tell me, according to the CDC or any of the others, why should you keep your nose covered with the mask? Why should your mask fit properly? What is the purpose? So please research why you're supposed to wear the mask, why it is supposed to fit properly, why it's supposed to cover your nose and not slide off like pants off of somebody's butt. I want to know the entire reasoning behind this. I think this would be a very good lecture assignment. And if you say that you looked it up online, I need a link. I want the website where you get your information. Yeah, so please, that's your lecture assignment. That is what you need to turn in under hybrid lecture assignment 2. Yeah, that should be pretty much it. Don't have a PowerPoint other than the lab one because we covered them both in class yesterday. I did a lot of talking and my voice was gone by the end of it, but we got it all covered. So that's it for this week. Email me if you have questions. You already have the email address. It's at the top of here and it's in your syllabus. So yeah, that's pretty much it. I will see you Monday when we are doing our osmosis lab, the shellless egg lab. I cannot wait. Oh, and you want to make sure you're doing that cell quiz because it's extra credit at the end of week 1, open throughout this week as well. And that will be on your exam, which opens next week. So yeah, there you go. All right, bye.